we're going to introduce about D-block in periodic table. And the first thing I want to explain, what does a D-block mean? So it's actually divided into a group by their electron configuration. And the D group D-block will have a common thing, which is the highest electron will always stay into the D subshell. And the thing is, they will fill the S block and then P block, and then they will fill into the D block. And the D block will have a 5 block, they can contain 10 electrons. For instance, if we're trying to find ions, Fe, and let's write down their electron configuration. So the first, they will have the first energy level, and the S subshell, and then another S subshell, and the P block 6 and 3 S 2, because in total they have 26 electrons, and then we keep going. And P subshell 6, and then things getting very trickier here. We didn't put D. We directly put instead we put 4. We fill energy level 4 and S, and then we put 3D there, and we put 6, and that's why it's called a D block. And that's the common thing about the D block, and that's what it is. And D block are known as transition metal, and the Chris will talk about their property now.
Adding on to what Will said about the physical properties of the D block elements, the D block elements in period 4 are all relatively active, which means that they can displace hydrogen in an acid that the element is placed in. Whereas in period 5 and 6 D block elements, they are less active and they have difficulty reacting with acids. The D block elements have a large charge radius and a large charge ratio. They're physically hard, they are very dense, and they have a high melting point and boiling point. When compounds are formed by these materials and elements, they are usually paramagnetic, which means that they usually leave an unpaired electron within the compound. Ions and compounds formed by D block atoms are quite colorful, and this can be seen most obviously in rust, which has a very, very deep red to it. D block forms compounds with noticeable catalytic activity, which means that they have higher reactivity with another compound when the reaction is within a catalyst. D block compounds are also stable in nature, so it is possible to find them outdoors.
In addition, I want to explain why the D block will have a so bright color, and that even exists in a normal condition. The reason they have a bright color is because the opening of the D orbit. The D orbit is a very complicated structure in 3D dimension. And that's why the electron will become very excited and achieve higher energy level, and that will lead to a bright color. And that's just the cause of the bright color. Another thing is the oxidization. They have very, very high possibility to become more oxidized states, as because the way they bond it, they can partially fill the orbit, or completely fill or partially fill. That's why they have so many oxidation states. That's it. Action.
All the elements of the D block show similar properties due to the presence of similar electron configuration of the outermost shell. The outermost shell of the configuration is n times s squared. Like all metals, transition metals are highly thermal and electrically conductive. Ductile, which means they can be stretched into a thin wire, and malleable, which means they can be molded without breaking.